Continue from the previous video, we talked about central limit theorem. The central limit theorem describes how the normal distribution, a bell-shaped curve, is connected to random sample average. We care about sample average because they estimate population average. So that's why in our demonstration, we use the United Airlines delayed information. So here is the almost 14,000 flight delayed data. So you can see here the distribution is very right skewed distribution. So we can consider that's a population distribution. And also we calculate the average delay is about 16.66. But like we say, even that's a population, we can just using the sample data to estimate the population, especially for the average. So that's why we do two things first. So the first one, we show you we using the sample size is 100. Then we do simulation for 10,000 times. So that's why you can see here, they kind of have the bell shape. So the interval is about 7 to 30. So 100 size is fine. So it kind of gives us the bell shape. So since we have the bell shape, we can estimate our average. And also we can calculate the average as well. So then we find out the average actually rises pretty close to our population's average. But how about we try bigger sample size? Okay, so here is this 100. So sample size 100. So that's our average. Also our average is 16.64. But also we show you the same thing. We can change the sample size is 400. Then we find out this one actually even more bell shape, right? So compared to our 100, they are more symmetric for the 400 sample size. And also you can see the interval also is narrow, kind of narrower than the size is 100. The same thing here, we can guess the average is around 16. And of course, we can just calculate the result, that's 16.6. So since 400 actually is more bell curve, how about we change to the sample size is 1000. So that's why you can see actually they take a much long time to run, because each time we take 1000 sample size, and remember we simulate 10,000 times. So we are waiting for that to finish that. So you can guess, when we were waiting, you can guess our distribution actually we are expecting is more symmetric and smooth bell curve we can simulate. So that's you see the result. Yeah, so here actually they are more symmetric. But the most important thing is the interval is narrowed. It's narrowed than, it's not as wide as the size, sample size 400 and 100. And of course, you can see here our average definitely is here. So then because they are narrower, so then we can see here is between 16 to 18. So if 17 is here, so we can more clear to see that's about 16.5. Because if we only see from the graph, of course we can find the average. So from the sample size 100, 400, 1000, the good thing is they are all look very similar to the bell shape, and you can see the larger sample size even more symmetric. At the end of last video, I also show you how about we change the sample size is 10. So that's why you can see if the sample size is 10, right? So then the shape is not really symmetric. Okay, and also we can guess even the average will go toward to the right. So then, but here it's not easier for us to guess the average from the distribution. Even we run to get the average is about 16.79. It's not too far from our population result. But now, how about here? We have the sample size 10, right? So then let's add more. So one thing is I want to show you, how about we change, here is the 10. How about we change to 5? Okay, so here is the sample size 5. Okay. So this one will not run so long, yeah, because each time we only take 5. So then you can see, right, so they are not as symmetric as sample 10. I think even closer to our population. So then the same thing, that's calculate our mean. Okay, so then you can see, yeah, even the mean is still very close, but we don't know exactly how much they will be different. But the most important thing is the distribution not easy to tell unless we really calculate the mean. So that's we show you, we're using the population data and we take different sample size from the average. So then here we talk about the central limit theorem. This one is help us to see the random sample average. If we take many random sample average, the empirical distribution will be close to the normal distribution as a bell-shaped curve. And we need to be very careful. The sample size, actually, we need to be large. As large as we can, so the result will be even closer and also more symmetric and narrowed as the normal distribution. So that's why regardless of distribution of the population, unlike earlier, our example, the population distribution actually is the right skewed. But the probability distribution of the sample average is roughly become like the normal distribution. So that's the central limit theorem. So think about, do you have any question? And also make sure you run our demo file to try different sample size, so then you can see differently and also see what you can observe even from there. Before we finish this lecture 26, so we do have one discussion question. We'd like you to work on that and also make sure you can find your peer lab exercise peer group to discuss with that. So here we say we're rolling a dice that's a 6 side. We do 1 million times. So which this histogram would you expect to have a bell shape? So check all that apply. So that's why we have 3 different histograms. So think about that before you go to see the answer. The first one is the histogram of the outcome for this 1 million row. The second one, the histogram that results from computing the average outcome of this million rows. The last one, the histogram that results from splitting the outcome into 1,000 groups. So that means here we have 1 million. So we break that into 1,000 groups, and each group have 1,000 outcome. And also we compute the average outcome for each group. So pause the video if you need before we go to see the answer. Okay, so I will give you answer now. If you are not discussed with your classmates, please pause that. I'll pause the video. You can wait to see the answer later. So actually that's 10 minutes. So otherwise, if you want to come back later. So the answer here we will talk about is about 10 minutes, 20 seconds. Okay, so you can come back later. Okay, let's see here. The first one, the histogram of outcome of this 1 million row. So that's me. Each time is what? Each time actually is either 1, 2, 3, 4, or 6. So we just want to see the outcome input, the outcome of this 1 million into the histogram. So that's why this one will become what? Because they are big size enough, so the distribution will close to the probability distribution. So that's why your outcome only 1, 2, 6, 3, 4, 5. 1, 2, 3, 4, 5. Sorry, I cannot talk. Okay, so outcome only 1, 2, 3, 4, 5, 6. So that's why each one actually, when you put it in the histogram, their result will be very close. So that's why it becomes a straight line. Okay. So then actually that will be probability, right? So that's why each one, the height will be 1/6. So that's about 16.67. Okay, so the first one actually is a straight line. The second one, the histogram that results from computing the average outcome of this 1 million rows. So actually, they just want to find the average outcome for this 1 million row. So that becomes they all add outcome together, divide by 1 million. So actually, this one is just a number. So this number will be close to 3.5. Okay. So then the number 3, the histogram result from splitting the outcome into 1,000 group, and each one have 1,000 outcome. So this one, like you do the sample size is 1,000, and we do without replacement, we do 1,000 times. So that's why even earlier we say central limit theorem, they will do with replacement. But with or without, for the big number sample data, it's not really affect a lot. So that's why this one actually, since they have good number sample size, good number simulation times, so then this one, right, they will get the histogram result will close to the bell-shaped curve, will close to the normal distribution. So that's our lecture 26 about normal distribution. So yeah, so after this lecture, you will work on your lab 8 worksheet. So that's just for discussion and no summation. Okay, so then that's our lab lecture 26.